Hello everyone, welcome to the demo on building and deploying application from scratch within Openshift. You can download the PPT and the code used in this presentation as below. You can just copy paste the link by using something like this, git clone and the URL, and you should be able to download the code. Coming back to our application is a telephone directory which displays username, country and phone number. Application has two parts, web app and MySQL database. Web app is built using Python and Flask framework. MySQL database holds user data being used by the web app. Pages displayed by the app. First page is a welcome page which will be saying like hello viewer, welcome. Please check /tl_dir for telephone directory details. When you go to tl_dir, it will come to the second page. It will be displaying the telephone directory like ID, name, country, and phone number. We need to know about containers and pods. But why? Pods are the basic building blocks of OpenShift. Pod is a group of one or more containers. What are containers? Let's find out why we need containers and understand them by comparing with virtual machines, as virtual machines are well understood. Let's have a look at the traditional system. On the physical machine, we have hardware, and on top of it, we have installed operating system. And within operating system, we have kernel space and user space. And within user space, we have applications installed like app 1, app 2, app 3. We can even have DB as well. Now, what are the problems with the traditional system? Security. As files of one app can be viewed by another app owner. Resource exploitation by any app. Let us say if this app is using more CPU and memory, this can result in CPU and memory crunch for other apps. So that means this app can exploit the complete resources of this machine. And if an app needs reboot, it impacts other apps as well. Let us say if there is a problem with this app and it needs a reboot, then for rebooting this, we have to reboot the complete machine, which impacts this app 1 and app 3 as well. Like this, we can have many issues if we are having more than one app running within a physical machine. In order to address problems with traditional system, we need physical or logical separation between applications. If we go for physical separation, we will end up having a large number of physical machines, which is not a viable option. So we have to go for logical separation. Virtualization and containerization provide logical separation for applications. Let's look at the virtualization and containerization and understand the logical separation. So if you see here on the hypervisor, we have two virtual machines and there is a logical separation between these two VMs. And also if you look at the containerization, on top of kernel you have two containers and there is a logical separation between these two. Let's try to understand more about containers by comparing them with virtual machines which are already well understood. So this is a table which displays the comparison between both. So containers are about virtualizing the operating system and its subsystems like network, file systems, processes. When you go to virtualization, it is based on emulating hardware or are about virtualizing hardware. In containerization, you will have single kernel on top of which you will have containers. In virtualization, you will have multiple kernels. Containers are initially embraced by service providers, and virtualization is initially embraced by enterprises. Under resource crunch, containers are stable than VMs, as only one kernel tries to solve problem. Under resource crunch, VMs running on hypervisors are unstable, as one plus kernels start to solve the same problem. Lightness makes the containerization far more dense and elastic. In virtualization, we'll have less elasticity and density. We need to know about Docker. But why? Docker is a tool for managing containers. Rocket is a similar tool like Docker, and OpenShift uses Docker. So we can visualize Docker as something like this. Within a machine in the user space, you'll have Docker, and it will be managing two containers. Of course, a Docker can manage a lot number of more containers, but Docker is basically a tool for managing containers. Our demo is consisting of three parts. Part 1, deploy application on a machine. Part 2, deploy application within containers. Part 3, deploy application within OpenShift. So starting with part 1, deploying application on a machine. Application can be depicted as below. On a CentOS 7 VM with IP address 192.168.121.9, we'll have a web app and a MySQL DB. So let's look at the setup which we will be using for the part 1. It is a CentOS 7 VM running on Oracle VirtualBox. Softwares that needs to be installed on the CentOS 7 VM are Python, Flask, Flask MySQL DB, MySQL, MySQL Server, and Git. I have given the commands that are required for the above as below. You can simply do a copy paste of these things onto your virtual machine, and that should have all the required things set up for you. Let me do it. I'll do a copy, Control C of all the commands that are given over there. Copy and then do a simple paste. Now it had started setting up the system for you. It should be taking a while depending on the speed of your internet and the capacity of the machine. So we will let it continue. It is installing the MySQL required stuff. Now we can see that all the required stuff are installed and the MySQL database has been set up with the passwords as well. We'll go to the next part. So now we will upload data to the database. MySQL server should already be running. Connect to the MySQL as below, then create table and upload data. So for creating tables and uploading data, things like that, you can simply do a copy paste of these things. But before that, we have to connect to the MySQL. So let me connect to the MySQL hyphen u root hyphen p, and the password is password itself. Password. So now we are connected to the MySQL database. Let's do a copy paste of the complete stuff. So I'm just doing Control C, copying everything, copy, and then doing just paste of these things. So now all the data that is required to be inserted into the database is completed with this. Now exit the database. Next step is we will download the application from GitHub as below. So you just need to do a copy paste of this, and that should get all the required code for you. So let me do that. P and paste. So here you can see it had downloaded. You can see it would have created a directory named Kiran-app. Running above command would download code to directory Kiran-app, which we have just seen. And now go to the directory Kiran-app/app and check the code in app.py. So now we will try to understand what is there in the app.py contents. Now let's go back to the machine. Go to the directory cd kiran-app and go within the directory app and do an ls, and you can see the file app.py. Now let's open this file and try to understand its contents. More app.py. So if you see, the first part, important part, is the MySQL connectivity required details. So here we have only one variable that is given, that is the host name, the host on which the database will be running. Apart from that, rest of the things are hard coded, like username, the password, and the database to be used. And if we go further in the code, we will see that there is the first page which is being displayed is present here. So it will when we go into the default route, it will be displaying hello viewer, welcome, and the stuff which we had seen in the past. And the second part is connecting to the this database, and it will be displaying the contents of the database in a tabular format. If we still go down, our application is listening on the port 5000. Let's go to the directory templates. Here you have one more file. Let's open this file, more test.table.html. This file contains the simple code for generating tabular format. That's it. Now let's go back to the previous directory. Now run the application as below. We'll just do it. Python app.py, and we are giving the variable as localhost because our database is running on the same machine. If your database will be running on different machine, you have to give the IP address or the host name. So now our application is started. Connect to the web browser and check the links below. Ensure no firewalls are blocking. IP address of my CentOS 7 VM is 192.168.121.9. You have to use the IP of your VM. So we have to connect to both of these URLs and check if we are able to access the application or not. Now we will connect to the web browser and type the URL. So it is already cached in my machine, so I'll just type this. And now it is connected. Here you can see it had displayed hello viewer, welcome. Please check the TL_dir for telephone directory details. Now let's just give TL_dir/TL_dir. And here you can see it had connected to the database and it had fetched the details and displayed it for you in a tabular format. This concludes our part 1 of the demo.